So in this lesson, we're going to have example 2 of graphing polynomial functions given in factored form. So this is our given. We're going to graph this polynomial function. My main point here is this negative here, okay? Be sure to consider that and don't forget that all the time. So I hope you're going to pause this video and really try to solve this on your own first. So we're going to get, okay, let's start. So we're going to get our x-intercepts. Okay, so we have to make y 0 and look for the values of x that will make this 0. So we're going to get equate it to 0, and so we will get our zeros as negative 3/2. So when this is 0, this negative doesn't matter for now because 0 times negative 1 is still 0. So we'll have negative 3/2 with a multiplicity of 2. We're going to have x equals 1 with a multiplicity of 3 and an x plus 1 with a multiplicity of 1. So since the multiplicity is even, this is repeated even times, we're going to bounce on negative 3/2. This is odd, so we're going to cross on x equals 1. This is also odd, so we're going to cross on negative 1. To get the y-intercept, we have to make our x equal to 0. So we're going to substitute 0 for x and calculate the value. Don't forget again the negative. So that will be negative, okay, so this will be 0, 3 squared, don't forget the negative here. Okay, and that will be negative 1 to the 3 and 1. So 3 squared is 9, negative 1 to the 3 is negative 1 times 1, and don't forget the negative. Okay, so that is 9 times negative 1 times 1 is negative 9. So our y-intercept is actually positive 9. Okay. So here, to get the end behavior, we're going to get our leading term. So don't forget the negative. Okay, so everything here will have its negative and negative. Okay, so to get the leading term, we said we are going to use the Pascal's expansion, okay, the first term, but as a shortcut, I hope you notice it by now, the Pascal's number will always be 1 for the leading term, for the first term, 2x raised to that, and this second term is always 0. So this will always be 1 and this will always be 1. So as if we are just raising the first term to that power. So that's what I will use. So 2x squared is just 4x squared. I'm going to raise this to the power x to the 3. I'm going to raise this to that power x. Then I'm going to multiply these 3 first terms of the expansion. And that's going to be 4x to the 6. You add the exponents. And so that will be negative 4x to the 6. Okay, so when you simplify, that's going to be negative 4x to the 6. So our end behavior will be, since this is negative coefficient, even exponent, so that would be like a parabola opening downwards, right? So this will be negative even, so it will be like a parabola opening downward, the end behavior, so that will be down, down. Okay, so now we can graph it. We can graph this we can graph it now. So that will be, so our x-intercepts are negative 3 halves, 1 and negative 1. So if this is your 1, so this is your 2, so your 1 and negative 2. So our x-intercepts are negative 1.5 with a multiplicity of 2. So that will be here a square. We will just touch it. Then 1 multiplicity of 3. We're going to cross, and negative 1 multiplicity of 1. So we're going to cross that also. So this will be bounce, cross, cross. Okay, bounce, cross, and cross. Okay, so our y-intercept is positive 9. Okay, so say positive 9 is there. And this will be a down, down. Okay, down and down. So we'll be going to have a down here and a down here also. And we're going to bounce there. Somewhere along the way it will turn and go up. And we're going to hit that one there. And we're going to, okay, so bounce somewhere along the way, it will go up, cross that one. We don't know where it will turn, and go all the way down there. Okay, anyway, something like that. Okay, so that's our graph. Now let's do the summary. Write your x-intercepts, your y-intercepts, write it also. Your end behavior, be sure you write it in math form. As x approaches negative infinity first, y approaches negative infinity, it's a down, down. As x approaches positive infinity, y approaches negative infinity. Okay, for our extrema, so we have an absolute maximum, the highest point somewhere between negative 1 and 1. So in interval between negative 1 and 1, do we have a relative max? A relative max, yeah, that one. Whenever we bounce, that's a relative max or a relative mean. So the point negative 3 halves, negative 3 halves, 0. Okay. And then the lowest point, none. And we have a relative minimum here. Okay, so absolute mean, no, none, and relative mean in interval between negative 2 and negative 3 halves and negative 1. In interval negative 3 halves and negative 1.